Probability is defined as the number of favorable outcomes divided by the number of total outcomes, which is basically good over total. That's the way you've learned it throughout your career. Okay. If you cast out if you're going fishing, you make 7 casts and you catch 3 fish. That means that the good is 3 and the total is 7. The way you write that is you write a capital P with parentheses and then whatever the good thing is. So the probability of catching a fish is 3 over 7, which we could write as a percentage. Could be 43%. So you have a 43% chance of catching a fish. Monifa has a collection of 32 CDs, 18 R&B, and 14 rap. As she is leaving for a trip, she randomly chooses 6 CDs to take with her. What is the probability she selects 3 rap and 3 R&B? So on top, we have to put the good thing. And on the bottom, we have to put the totality of what she's doing. Okay? So for it to be a favorable outcome, we need 3 R&B CDs and 3 rap CDs. Does the order we choose them matter? No. Okay? So we're going to put good over total, and the order does not matter, so we're going to use combinations. So, on top, you think, how can I get 3 R&B CDs? What you would do, how many different ways can I get 3 R&B CDs? That would be a combination 18, 3. I'm just thinking about the R&B CDs right now. You have 18 of them. You are choosing 3. For the rap, you have 14, and you are choosing 3. We're trying to figure out how many different ways we can have 3 and 3. You know, you've got 18 R&B CDs there. There's a whole bunch of ways you can pick 3 of them. We just have to figure out that total. I could have asked that question yesterday on your worksheet. You have 18 R&B CDs. How many different ways can you pick 3 of them? That would have been a question yesterday. It would have been a combination. That's just part of the question today. The totality of what she's doing, which is the bottom, is she has 32 CDs and she is choosing 6. That's in general what she's doing. She's choosing 6 of 32 CDs. We figured out how many ways you can do 3 and 3. And we've put that over how many different things you can do in total. Now you just have to do that on your calculator and get a decimal, which you could turn into a percentage, the probability that that would happen. On top, I get 297,024. And on the bottom, I get 906,192, which gives me some sort of probability of around 33%. 33% of the possibilities have 3 R&B and 3 rap. A board game, Scrabble, is played with tiles and letters on one side. There are 56 tiles with consonants and 42 tiles with vowels. Each player must choose 7 of the tiles at the beginning of the game. What is the probability that the player selects 4 consonants and 3 vowels? So what we're going to do is we figure out how many different ways can we select consonants. Then how many different ways can we select 3 vowels? That's the top. Over how many different ways can we select 7 tiles? That's the total. Okay, does it matter the order you select your tiles in Scrabble? Nope. So let's start with consonants. There are 56 consonants. How many do we want to select? 4. in our favorable situation, there are 42 vowels. We want to select 3 in our favorable situation. Our favorable situation is usually at the end of the question. They'll say, what is the probability of this happening? And that's what you want to put on top. Sir. The bottom is what you're doing in general, which is you are selecting 7 tiles out of 98 total tiles. And to add the 56 and the 42 together. Okay? So we did what was good on top, and we do the total of what we're doing on the bottom. See if you can come up with some sort of percentage. I ended up with a huge number on top. The bottom number was scientific notation, which is okay. Your calculator still can read it. I ended up with a percentage of around 30%, give or take. Well, Ramon has 5 books on the floor, 1 for each of his classes. He's going to put the books on a shelf. If he picks up the books at random and places them in a row on the same shelf, what is the probability that his English, Spanish, and Algebra 2 books will be the leftmost books on the shelf, but not necessarily in that order? Okay, so what he wants, basically, is he wants the English, Spanish, and Algebra books on the left, and the chemistry and the history books on the right, but he doesn't necessarily want them in that order. So that would be acceptable, or that would be acceptable, or that would be acceptable, and he wants to know how many different ways can he do that. Or what's the probability that if he just throws the books up there, he gets something like that. So what we have to figure out is, how many different ways can the E, S, and A go up there like that? How many different ways can the CH go up there like that? Over how many different random ways can 5 books go on a shelf? Okay, so does order matter? No. Well, I think it does. Putting the ESA up there is different than putting ASE up there. So the order of the books matters. So this is going to be a permutation problem. Because we have 5 books. If the order didn't matter, 5 books would be 5 books. A group of books. But now we're putting them in specific order. So now we have to use permutation. So how many different ways can the E, S, and A books go on the shelf? That is 3P3. You have 3 of those, and you're putting all 3 of them on the shelf. Okay? So we're trying to figure out how many different ways can you do those books together. And then for the C and the H, well, that's 2, because how many different ways can 2 books be put on a shelf? In terms of a permutation, though, it's 2 choose 2. But the answer is 2. Over the totality of what you're doing, which is you're putting 5 books on a shelf. You have 5, and you're putting all 5 on the shelf. So we took the ESA books, and we did a permutation because the order of the books matters. We did a permutation on CH, which really didn't need to do because there's only 2 ways you could put 2 books on a shelf, over what we were doing in total. So that's your calculator problem right there. On top, you should get 12. And on bottom, you should get 120, which is 10%. Bob is moving, and all of his sports cards are mixed up. 12 cards are baseball, 8 are football, and 5 are basketball. If he reaches in the box and selects them at random, find each probability. So first I'm going to do number 8. The probability that he reaches into the box and selects 3 football cards. Am I selecting 3 specific cards, or am I just selecting 3 football cards? Just a group of them. So what am I going to use? C, combination. So a favorable outcome would be I'm going to have 8 football cards, and I'm going to choose 3 of them. That's a good outcome in this problem. Choosing 3 of the 8 football cards over the total, which is 12, 8, and 5, 25, and I'm choosing 3. So the total that I'm doing is there's 25 cards in this box, and I'm picking 3 out. That's what I'm doing. The good things that would happen is if I chose 3 of the 8 football cards. So your calculation for number 8 is combination 8-3 divided by combination 25-3. If you do that correctly, you should get 2%, roughly. Okay, let's do number 9. The probability of 3 baseball would be combination 12-3 over the same denominator, combination 25-3, because you have 12 baseball cards. So it's 12-3 over 25-3. Doing number 9, and on your calculator that should be 10%. The fact that there are more baseball cards in the box makes your probability greater. Everybody following? All right. Number 10. Now they've put 2 things in there. The probability of 1 basketball card and 2 football cards. So we'll take each one separately. How many different ways can I choose a basketball card? Well, if I have 5 and I choose 1. So there's 5 different ways. And then football, there are 8, and I choose 2. So that is the top of the problem. 5, choose 1. I have 5, I choose 1. I have 8, I choose 2. Over the same denominator, 25-3. And I get, in that case, roughly 6%. I want you, right now, to do 11, 13, and 15. And we'll go over those in a couple minutes. Okay, the answers to 11, 13, and 15. 11, 5% roughly. 13, 21% roughly. 15, 0.
Do you know what the answer to 12 is?
No, not off the top of my head. The Karubas have a collection of 28 video movies, including 12 westerns and 16 science fiction. Elise selects 3 at random to bring to a sleepover. Find the probabilities of each selection. So, the probability of 3 westerns, does it matter the order she grabs them? Nope. This is the same as the sleepover question from the other day. Except we're dealing with the Karubas today. So it would be combination 12-3 over combination 28-3. 7%. These are the same type of problems that we just did. So instead of baseball cards, it's movies. So for 6, you'd have combination 12-1. I just have the answer, 44%. It'd be combination 12-1 and times combination 16-2 divided by combination 28-3. Okay, let's move on to the next page. Now these are even easier. In this case, we'll do number 10. See if you can do number 10 all by yourself. Because they just want you to take, you have to just find the total number of students. And then put the number in that class over the total. So the number of sophomore female students would be simply 145 over the total, 697. You have to add up the total and get 0.208. It said decimals rounded to the nearest thousand. So there's no combinations or permutations involved there at all. That's more of a grade school probability question. All right. Now, odds. Odds are not probability. They're written a little bit different. Odds can be written good over bad, which is the way the book defines them. But most of the time in the world, they're written bad over good, or bad colon good. In class, we'll write them good to bad, since that's the way official math people do it. Okay, but if the horse race says that the horse is 50 to 1, that means the horse is going to lose 50 times and win once. Okay, or 2 to 1 is a favorite. That means the horse is going to lose twice and win once. Okay, the Cubs or whatever, I think they're like a 7 to 2 or a 9 to 2. That's the odds of them to win the World Series. That means that if this season were played over and over, they would lose the World Series, or they wouldn't get there 7 times, but they would win it twice. And that's very high odds considering there's 32 teams, and usually the best team doesn't win. So anyway, good over bad, which is different than probability, which was good over total. If the probability is 1/4, how many bad outcomes are there? 3. Because 4 is the total. So if the probability is 1/4, the odds would then be 1 to 3. Good to bad. So let's do the top 3. I've given you the probability. I want you to find the odds of the event. Correct answers here. 5 to 3. I write odds with a colon. That way I differentiate easier. You can write them as a fraction. That way I know my probabilities are fractions and my odds are with the colon. It doesn't really matter though. And then I want you to change those odds now to probability. And they have the odds listed as good to bad. So change those now to probability. Correct answers. 2/3, 8/17, 4/5. Everybody doing okay?
Fantastic.
Oh, that's all I got.
Oh,
We'll work
bummer.
on those tomorrow, kids that are here.
Sounds good.